Hi everyone, welcome to lesson 6, well done. You've made it to the 5.3 work. Today we're going to be looking at Pythagoras' theorem and trigonometry to solve three-dimensional problems. There's two main types of questions that I'd like you to be able to do today, and I'll go through examples for both. First of all, we have questions like this one. Find the distance ED. So E is here and D is here in the 3 diagonals. So we need to find the distance across here. So if in fusion it's from this point down to this point. So we need to slice it like a box open to go from here to here. So you can see here that this is E and this is D. So we want this distance across here. So first of all, if we look at the shape from the top view, we've got Pythagoras' theorem here with a side of 3 and a side of 4. And then we've got Pythagoras' theorem here. So this distance, which is 2, and the distance that we calculate, this distance here, makes our right angle triangle. So it's good to be able to see that, and it can be confusing for some students. So hopefully this 3D model will help you. Using a box might be helpful as well. So like a shoebox. So first of all, we need to use Pythagoras' theorem. So we've got a distance of 3 here and a distance of 4. So the square root of 3 squared plus 4 squared, which gives us 5. This distance here is 5. So this distance is 5. This distance is 2. So now we can use Pythagoras' theorem. 2 squared plus 5 squared is 29. The square root of 29 is 5.4 units. Next kind of problem is this one. So from a point A that is due south of a flagpole that's 100 meters tall, it's a very tall flagpole. So the flagpole's here. So if due south is down here, when we look up, this angle here is 35 degrees. So this is this part of the question. The top of the same flagpole is observed with an angle of elevation of 22 degrees from a point due east. So if east is over here, the angle up here would be 22 degrees. What is the distance from A to B? So A is over here, B is over here, so we need to find this distance across here. And noting that this is a right angle triangle, because this is south, this direction was south, this direction was east. Our normal compass rose looks like this, south. east. So it looks like this. So the first diagram is this one. It's just drawn in 2 dimensions. So it's a right angle triangle, 35 degrees, 100 meters. So with 35 degrees here, our opposite is 100, adjacent is S. So tan 35 degrees is 100 over S. S equals 100 divided by tan 35, so these two swap. Times by S divided by tan 35 gives us 142.8. Then for this triangle, the east one, we have 22 degrees, opposite is 100, adjacent is E. So tan 22 degrees is 100 over E. Same process, times both sides by E, divide by tan 22, give us this line, which is 247.5 meters. So now we know this distance and this distance. So the 142 is here, and the 247 is here. Should be 247, giving us AB equals this number. 285.7 meters.